Acids and bases play an important role in chemistry, but they're also in our everyday lives. What are some acids and bases that you already know about? Okay, so citrus fruits are definitely acidic. It's citric acid, one of the acids in there. How about vinegar? Did you think of that? It's acetic acid in vinegar. And how about soda? Did you think of any soda or carbonated beverages being acidic? And last one is stomach acid that I thought of. Very acidic. It's important for breaking down our food that it's really acidic, but if it ever leaves the stomach, you know how bad that can burn. So on the basis sides of things, probably a little bit harder to name. We tend to be more familiar with acids than bases. But if you've ever used ammonia to clean, that's a base. Baking soda is basic. And soaps are actually made by adding base to fat or oil. And so soaps contain bases. And then finally, if you've ever used like lye to relax your hair or straighten it, that is a strong base as well. So we've got acids on one side of the spectrum, bases on the other, and of course, right in the middle, something that's neither an acid nor a base is called neutral. And the best, most common example of that would be pure water. So let's talk a little bit about some properties of acids and bases. You'll also see bases called alkaline, so just be familiar with that term. Acids tend to taste sour. When you picture eating citrus fruit or vinegar, picture your face kind of puckering up from that sourness, whereas bases tend to be more bitter. Now, of course, we don't taste things in the lab, so this isn't a great measure for us. But you can also think about how they feel on your skin. Acids tend to sting a bit or burn, whereas bases tend to feel slippery. And again, the reason that soap is so slippery is because their bases combining with the oils on your skin or the fats that they've been made with. And then finally, the pH scale. Acids fall below 7 on the pH scale, and bases are above 7, with pure water being neutral right at 7. Here's a little pause till we can take a quiz. Do you remember the chemical formula of NaHCO3? Or are you feeling a little stumped? All right, so question for you. How can we measure pH in the lab? We talked about this pH scale. We talked about acids being low, below 7 on it, and bases being above 7. We know it's a scale that goes from about 0 to 14. What are some ways you've measured pH in the past? Awesome. So hopefully, I know that you've used pH paper in chemistry with me. Maybe you've used litmus paper in another class before. So all of these substances are called indicators, and they're substances that change color in the presence of an acid or a base without actually being changed themselves. And so the one that I want to go over today so you can make it yourself is an easy one to make at home. It's red cabbage indicator. And so it gives a really incremental scale of pH, and it's super easy to make. So all you'll need is a red cabbage. I only used about a quarter of this, and I got way more than I needed. So you even need less than that. Just cut that into pieces, put it into a bowl, and pour some boiling hot or really hot water over top. So, of course, be careful, wear goggles, use oven mitts, and ask for your parents' permission. Let that sit for about 10 minutes, then strain off the liquid, and you'll have your red cabbage indicator. Now you can go ahead and conduct your experiment by first predicting and then testing the pH of various random household items. If for any reason you don't feel up to doing this lab yourself, that's fine. I've made a video of the one that I did that you can watch. I want to hear how your lab went. If you do it, tell me what substances you tested, what your predictions were. If you didn't have a chance to do the lab,